Hello, welcome to Quipper Video. There are 118 elements that compose our universe, but when the universe began with a Big Bang, it started out with no elements at all. Where did these elements come from? In this chapter, you will give evidence for and explain the formation of the light elements in the Big Bang Theory. The Big Bang Theory is the leading explanation on how the universe began. At its simplest, it talks about the universe starting with a small singularity, then expanding over the next 13.8 billion years to the cosmos we know today. According to NASA, within the first thousandth of a second following the Big Bang, all the matter in the universe was in the form of a hot gas of charged particles. Then, in the first second, the surrounding temperature was about 5.5 billion degrees Celsius. It was too hot and dense. The cosmos contained a huge amount of fundamental particles: protons, electrons, and neutrons. The particles moved about freely and did not come together to make atoms. Only 3 minutes later, when the universe had cooled from 10 raised to 32 to 10 raised to 9 degrees Celsius, did nuclei formation begin. This nuclei formation is known as the Big Bang Nucleosynthesis. Big Bang Nucleosynthesis, also known as primordial nucleosynthesis, is the process of producing the light elements during the Big Bang expansion. It is believed to have happened between 10 seconds and 20 minutes after the Big Bang. Big Bang nucleosynthesis formed the nuclei of the following elements: hydrogen, deuterium, tritium, helium-3, helium-4, lithium-7, and beryllium-7. Remember what nuclei are made up of? Protons and neutrons. Wait, where are the electrons? During the first few minutes after the Big Bang, electrons were still roaming free, so they do not combine to the nuclei yet to form neutral atoms. So let's focus on the nuclei first. As expected, the atomic nuclei of the lightest element, hydrogen, was formed first. What makes up the nucleus of hydrogen? Just one proton. So protons were technically the first nuclei. Deuterons were the second nuclei to be formed. They are the nuclei of deuterium. They were made when protons and neutrons fused and emitted photons. We can read the nuclear reaction equation as pure proton plus N or neutron yield H2 or deuterium nuclei plus gamma rays. Recall that gamma rays are composed of energetic photons. What's next after deuterons? The tritium nucleus. Two deuterium nuclei were fused to create a tritium nucleus with one proton and two neutrons. In this equation, you can see that there were no particles lost in the reaction. There were two neutrons and two protons on both the left and right sides of the equation. So, hydrogen nuclei formed first, followed by deuterium nuclei, called deuteron, and then tritium nuclei. Deuterium and tritium are actually isotopes of hydrogen. Remember what isotopes are? Isotopes contain the same number of protons, but differ in the number of neutrons. So, they have different masses. It's like they have the same identity but they differ in weights. What happened next after the formation of the isotopes of hydrogen? The nuclei of the next element, helium, were formed. When the tritium nucleus came across a proton, the two particles combined into a helium nucleus with two protons and two neutrons, known as helium-4. Another path that led to helium was the combination of two deuterium nuclei to produce a helium nucleus with two protons but only one neutron, helium-3. As you see, helium also has two isotopes, helium-4 and helium-3. Helium-3 can be converted to helium-4, the more stable isotope. When helium-3 came across a deuterium, they fused to form a helium-4 and a proton. After the formation of helium, the nuclei of the next element, lithium, were formed. Lithium-7 was produced from the nuclear fusion of helium-4 and tritium. It has 3 protons and 4 neutrons. Lithium-7 was actually unstable, so right after its formation, it decayed spontaneously to form 2 stable helium nuclei. Another unstable nucleus that formed was beryllium-7, which has 3 neutrons and 4 protons. It was produced from the nuclear fusion of helium-3 and helium-4. Being unstable, it decayed spontaneously to lithium-7 by releasing a proton. The early soup of particles would have been impossible to look at because there was no light shining through it. About 380,000 years after the Big Bang, the universe cooled down and the particles began combining to form neutral atoms. Their combinations allowed light to shine. Yes, the first neutral atoms were formed, but these were only the two lightest elements, hydrogen and helium. That's pretty much it. It took 1 billion years before the next element of the periodic table, the neutral lithium atom, was formed. Such a long time for waiting. So, hydrogen, helium, lithium, and beryllium were formed during the Big Bang nucleosynthesis according to astrophysicists. Now the question is, what made them think so? Their answer is the abundance of the light elements. Scientists calculated the abundances of primordial material based on the Big Bang theory. They found out that the total mass of the universe would have been 25% helium, 0.01% deuterium, and even less than that would have been lithium and beryllium. Hydrogen and helium were the most abundant elements in the universe. These primordial abundances have been tested. Scientists have measured abundances of primordial material in unprocessed gas in some parts of the universe with no stars. They found out that indeed, hydrogen and helium are the most abundant elements in the universe. The correlation between the observed abundances and predicted abundances is the major piece of evidence for the Big Bang theory. So, the whole process of producing the nuclei of hydrogen, helium, lithium, and beryllium and their isotopes happened over 20 minutes after the Big Bang. Then the universe became too cold and sparse for further nuclei to form. So, how were the nuclei of other elements like oxygen, carbon, and iron created? We will find that out in the next chapter. Let's recall what we have learned today. We learned that Big Bang nucleosynthesis is the process of producing the light elements during the Big Bang expansion. It is believed to have happened between 10 seconds and 20 minutes after the Big Bang. It gave rise to the following elements: hydrogen, deuterium, tritium, helium-3, helium-4, lithium-7, and beryllium-7. Now, where did the elements come from? We now know that they were manufactured in some form of cosmic alchemy. The light elements were formed during the Big Bang Nucleosynthesis. The heavier elements? We'll find out soon. Thank you for watching and see you in the next video.